So I'm just gathering everyone over it now.
Yeah. Hello, everyone. Hello, everybody online as well. I'm the budget Pete for today, so I don't have any slides to do the intros that are usually there, so I'm going to have to try and wing it. But yeah, got it nuts. Thank you to our sponsors. It's the usual thing to say. Quite a few of them. We got, I know, Rebel Recruiters. They're sponsoring the pizza that I'm going to get in a bit. The building, CGI, they're called now. What else is there, Jess? I've got to remember
Tech
them.
First is the
Tech
next
Fast,
thing as
yes.
well.
Yeah. In the morning. What was the other one?
And Not So IoT you want to mention as well.
No, not IoT. And isn't Pete's thing, just Pete himself. Go hire him. Um,
One quick one.
yeah.
So, not expecting the fire alarm to go off. If it does, out the door you came in, through the door to your immediate right, downstairs, everybody out by the statue at the bottom. Cool. Awesome.
No, but sorry, it's not online. If you have a fire, that's your own problem.
Yes.
It's basically it. Oh, there's usually a thing about if you want to be an MVP, go and talk to Jess and Pete. I think that's roughly it. Shall I hand over to you now?
Yeah, can do.
Go for it. There you go. My job done.
Cool. Thank you, Connell. Cool. And if you notice at any point that I'm, not speaking right into the microphone online, do just say and shut up. And hello, everyone. Thank you for coming along in person. So my name's Adam, and I'm going to jump straight in with some really scary code on the next slide, or I'm going to try to if this button clicker works. There we are. So on the screen at the minute, I've got an unnamed programming language. Don't worry if you're not a technical person in the room. I'll guide you through it very carefully. So in this unnamed programming language, on the very first line, I've got some console.log statement there where I'm doing 3 minus 1, and that's going to print into the screen. And that little bit of grey text, the comment on the right-hand side, is telling you what the output is. So in this program language, 3 minus 1, print into the screen, gives you 2. I think we're all good. I agree strongly with that. The next line down, we output to the screen 3 plus 1, and that gives 4. Again, I'm pretty happy with that. The next line down, the third one, we've got the character 3 minus 1, and that gives 2. And I can kind of scratch my head and go, okay, yeah, I can just about get my head around that. And then my question to all of you is, what does the fourth line output? So this is the character 3 plus 1. And I've got 4 options at the bottom to help you. You don't necessarily have to put your hands up. I'm not going to put anyone on the spot or anything, but just have a think in your head which of these 4 options you think is the most sensible. So we've got basically 2, 3, 4, or 31. Someone in the back said doing a sign with their fingers to show. I've just maybe given away the answer of which letter it is. I'll give you 5 more seconds to have a think about which answer you think it might be. Okay, so you might be horrified, just as I was, to discover the answer is actually 31 because it concatenates them, which is a little bit silly, maybe. Well, I think it is anyway. Anyway, maybe that was just a one-off. We'll look at another example. In this bit of code, we've got the variable x, and we're letting it equal an array with 1, 2, 3 in it, added to an array with 4, 5, 6 in it. And again, I'm putting it out to the screen. And we've got 4 options again. And the first 2 options are very, very similar. They're just the numbers 1 through 6 with commas between, except the first option doesn't have a comma between the 3 and the 4. Option C is element-wise addition. So we've got 1 plus 4 given 5, 2 plus 5, 7, 3 plus 6 given 9. And then option D, we've got the 2 arrays appended to one each other. So again, I'll give you maybe like 10 seconds to just have a think about which one you think might be the most sensible. Cool. I think this is the least obvious option, but it is A, which I found very, very surprising. Out of the 4 options, that's the one I would be least likely to pick, I would say. And we've got one final example here, which is a bit of an infamous one, where, again, we're putting it out to the screen, and I've got the string B added with string A, and there's 2 add signs in the middle there, and then string A added with string A. And the options are banana, banane, baba, and baba. That was really bad pronunciation. I'm not going to catch you out with this one. the answer for this one is option A. It's banana, which is quite funny that it prints that out. But again, from that order of operations, it's not something that I think is necessarily obvious or intuitive. So anyway, you might have guessed that this programming language was JavaScript. In actual fact, there are a few more examples of this. If you go to this link, bit.ly/WTF JavaScript, by the way, that path is usually people's reaction when they see those examples, WTF JavaScript. Yeah, there's some interesting little quirks about the syntax and how it behaves. On the right-hand side here, we've got the 2025 Stack Overflow survey, which showed JavaScript as the most popular language that people were either using or wanted to use more of. So despite these quirks, it's still obviously very widely adopted and used every day by lots and lots of different people. Maybe one of the reasons for that and the driving factors is the fact that the web is obviously an instantly cross-platform way of deploying your app. That's a very obvious thing to say, but, and then, yeah, despite these quirks, people do use JavaScript, but maybe people want to get around some of those problems by, for example, using TypeScript, which basically introduces types into JavaScript. It then transpiles to raw JavaScript to then be interpreted on the browser. And one of the options and kind of the motivating things for today is something called WebAssembly, which is another way of natively running code in a web browser. So today has two main topics. I'm going to give you a brief summary of both of them. We've got WebAssembly on the left, which is sometimes abbreviated to WASM. I don't know quite why they picked those letters out of WebAssembly to abbreviate it to, but they did. WebAssembly runs natively in browsers, much like JavaScript does. It's a language you compile to, but it has a lot of languages that support compilation to WebAssembly. And rather than replacing JavaScript, it kind of complements all the things that JavaScript is not so good at. And on the right-hand side, the other sort of 50% of today's topics is something called Blazor, which is an interactive web framework from Microsoft, which is C# and .NET based, which I guess is part of the reason why I'm giving the talk at .NET Knots tonight. So with that motivation out of the way, say hello again. I'm still Adam. Nice to meet everyone. And today's talk is going to take this rough structure. So I'm going to give you a little bit about my background, so you might find it interesting and see where I'm coming from and maybe why I'm so excited about Blazor and WebAssembly. I'll give you a brief introduction to Blazor, also basically an introduction to WebAssembly and its differences from JavaScript. And then I think we might have a pizza break, right, Connell?
Mm-hmm.
Excellent.
Ordering it right now.
Yeah, so point 3.5 is pizza. At home, you might have to provide your own pizza, sorry. Maybe preheat the oven now. And then we're going to move on to some interactive demos at point 4. I do want to point out that I'm definitely not an expert at Blazor and WebAssembly. And given that I'm at .NET Knots, there's probably people in the room who know more than I do. So if you have any technical questions, please direct them to some other people in the room. But basically, the focus of today's talk is to get you excited about Blazor and get you excited about WebAssembly. So very briefly, my background, before 2016, I was still in education and I was just kind of monkeying around with software and kind of building up some sort of fundamental skills. Circa 2007-ish, my dad introduced me to websites with HTML and CSS. We did some fun little projects together. And we very quickly moved on to using PHP to basically generate some dynamic content in those websites. And I had the opportunity to do some cool little websites for like family and friends, like local businesses as well, which was some really interesting experience when I was basically still a child, which was really, really cool. The blue one, underneath that on the bottom left, I then moved to Nottingham in 2016 and studied 2 degrees here. And in the second degree, I am specialised in studying blood flow in the placenta, which is really, really interesting. I kind of specialised in basically writing the high-performance software for running these blood flow simulations. So that was mostly written in Fortran. If you haven't used Fortran before, it's a real fun language to program in, and also bits of Python as well, which is fun for different reasons. I always had the amazing opportunity to do some teaching in Python when I was at the university as well, which was really, really cool. Leapfrogging slightly down to the bottom right in red is where I currently am at the moment, which is a company called Capital One. We do basically credit cards, and I mostly do back-end engineering, kind of mostly in Java. We work in an area of the business called customer engagement, which is basically like existing customers, what services can we provide for them? So, for example, if you want to update your preferences in your account, that's the kind of stuff our team deals with. And then taking one step back, in the top right, is a company I worked for last year called Savoy Systems. Savoy Systems, and they make ticketing software for cinemas and theatres. So if you go to the Savoy Cinema on Derby Road in Lenton, they use our software, and it does everything from selling you drinks to buying your tickets online. Most of that code base is in a language called Delphi, which is a bit of an unusual one. But more and more recently, we've been, well, I say we, not me anymore. They have been moving their code base over to C# on the front end. And that's when I first got introduced to Blazor, because some of their client-side apps do use Blazor now. So I'm now going to talk a little bit about Blazor. But before we get into Blazor, I'm going to give you a brief history of interactive web apps. So if we think all the way back to the 1990s, I was alive in the 1990s, but only just, so I don't remember much of it, but I was around. We had something called Web 1.0, where we had mostly static websites. Later on in the 1990s, we had languages such as PHP and ASP come along for when we wanted to have some dynamic content. And importantly, because I mentioned JavaScript this evening, I thought it was important to point out that JavaScript came along in 1995, which was the first language that allowed you to do some client-side dynamic code, which is really, really cool. I've also got some JavaScript trivia for you, in case you're interested. I know I kind of poo-pooed on JavaScript earlier in the talk. I promise it's still obviously a very useful language. But interestingly, JavaScript, when it was first introduced, was designed as the language for the masses. So it was meant to appeal to both technical and non-technical people, which I think is maybe one of the reasons that the syntax is so forgiving. It's because it needs to appeal to kind of both audiences now. Also, another bit of trivia. This will definitely come with a pub quiz one day, I'm sure of it. It was originally called LiveScript. But at the time when JavaScript was being released, Java itself was quite popular. And apparently they changed the name as a bit of a marketing ploy to improve adoption rates by calling it JavaScript, because I think it might get a bit confused and think that JavaScript might be better than it is. Sorry, I do like JavaScript, I promise. Moving on to the next tile, in the 2000s, we started getting interactivity in the browser with things like Ajax and jQuery. And I certainly remember when I was in primary school, when I was meant to be concentrating, I was playing a lot of Flash games. Moving on to 2010-ish, we started getting SPAs, or single-page apps, with things like AngularJS. And then slightly later on in the 2010s, we got some more of our modern JavaScript frameworks, such as React. In 2017, WebAssembly was officially released. And from the start, it's had input from the makers of Chrome, Edge, Firefox, and WebKit, i.e. the four big web browsers, sort of styling exactly what the spec for WebAssembly should look like, which is obviously really important if you're going to have some things that run on web browsers, that you have the buy-in from all of these browser makers. The next box is over in 2018, is when Blazor was first introduced. It was originally an unofficial project, and the word Blazor is made up of browser and Razor. If you don't know, Razor is basically C# embedded in HTML code, so you can make basically dynamic web pages. And then I don't know quite how they got from browser to Blazor, because there's no L in browser, but they did, and they called it Blazor anyway. And then on the final box on the right-hand side, in 2020, that's when Blazor was officially released, adopted by Microsoft, and it came with WebAssembly support baked in from the beginning. So let's talk a bit more about what Blazor is. So I think I've already mentioned, it's a web framework from Microsoft. It's an SPA, i.e. a single page app. So basically it renders once and then manipulates the DOM to make its page changes. And it uses Razor. So I've got a little snippet of Razor on the right-hand side here. Again, if you're non-technical, don't worry, it's not that scary. I'll talk you through basically what this page is doing now. So we can kind of ignore the top two lines. These are some C# things to do with how you set up the components. But then on line 4, we've got something that looks a little bit like a HTML tag. This is actually another Blazor component that you can go off to, which will be sort of a really powerful way of designing your Razor components. And basically, all this is doing really is just setting the title in the head tag of your HTML, so you get a nice word that appears in your tab at the top. Down on line 6, we've got a standard HTML heading 1 tag with the word counter inside, which gives you the big counter here on the left-hand side on this little snapshot here. And then on line 8, we've got something interesting going on. So we've got a standard paragraph tag, which is in HTML. Then we've got the word current count, and then we've got a little @ symbol, followed by this camel case variable of current count. I mean, not camel case, what's the other one where it's snake case, thank you. And in actual fact, this is actually a C# variable. So if we jump down to the bottom here, there's a little purple segment between these braces with this at code. And this is basically the makings of a C# class. So we've got a private local variable called current count, which is initialized to 0. And that's why we can see 0 next to current count on the left-hand side here to begin with. And we've got one method inside this class, which is called increment count. And basically what it's going to do is every time it's called, it's going to add 1 to current count. And then the last thing to point out, the only thing I haven't mentioned on the right-hand side, is there's also a HTML button there as well, which has an on click and then increment count. So basically the way this should work is every time you click the button, it should increment the number. But what's really cool, I'm going to play the video on the left-hand side now, is the number actually updates in real time as you click the button, which I thought was kind of cool. So that's very basic how what's going on with Blazor here. So something I didn't mention was basically there's a few different ways of hosting your Blazor project. I'm going to go through the main 6 now. So there's these 4 indented ones and then the 2 at the bottom. I'll talk about them very, very briefly. So in the most simple case, you've got a static way of hosting your Blazor app. So imagine you've got your .NET runtime or your C# server running up there in the cloud somewhere. And this little gold star is basically indicating that's where the content's rendered. So on your C# server, you render the page and you're just basically sending down a HTML page to the client device and then they see the web page. So this is really super simple. This is the same way that ASP works and the same way that PHP works. You generate on the server and you send a HTML page down to the client. If we move on to interactive server now, this one's a bit more interesting. All of the rendering still takes place on the server up there in the cloud somewhere. But we now have two-way communication between the server and the client, which is maintained by a WebSocket. So when the page is rendered, it's sent down to the client device, but then also things like button clicks, i.e. like on the previous slide, when I was incrementing that counter, it's sending back that button click event to then update the state in that C# class to increment the variable over on the C# server. Interactive WebAssembly is a little bit interesting in that you still have your .NET server up in the cloud somewhere. Sorry, I keep pointing out. I know there's not a cloud with servers in it. I know, but it's funny to think it is. But importantly, I don't know if you saw the little gold star move from the right to the left, but now all of the rendering takes place in the client device. And the way that happens is basically you've got a WebAssembly compiled version of the .NET runtime running in your client's web browser. So when you visit that website, there's basically it becomes twice as hard to maintain actually the code base because you basically maintain a server-side C# application and a client-side C# application. But Blazor will take care of all of the communication, keep them in sync and things like that. It does lots of sort of clever things for you. And then interactive autos is a really awkward and interesting one. I might be able to demonstrate how this works in the demo later. I've not been able to do it reliably. But basically, the auto means that Blazor itself decides what rendering mode it's going to do, if it's going to do server-side or it's going to do client-side. And that depends on a few things. But one of the applications for using interactive auto is this interactive WebAssembly one actually takes maybe a little bit longer to download. And because the reason for that is because it's not just a HTML page that you're sending down to the client, you're also sending all the WebAssembly files, and then it needs to initialize the page, and then it needs to render the page. So there's actually a bit of a delay for the interactive WebAssembly version. So this auto one tries to get around by that, but basically saying, what's going to be the quickest here? Does the client already have the files and can I render it straight away? Or should I render it server side, send that down, and then also send the WebAssembly files in the background for it to load at the next time? The next example is WebAssembly client. You'll notice that we've now just got the arrow pointing once, a bit like the static version. So your server here all it's doing is just serving the WebAssembly files. It's not actually got any sort of C-sharpness about it or any state management. It's just serving the files, and all the rendering and all of your client code is sitting in the client device. And the final one is a bit of a weird one. It's called hybrid. And one of the examples of using the hybrid hosting model is in .NET MAUI. MAUI stands for multi-platform app user interface. Again, with acronyms this evening, they've missed out the P, I think, in multi-platform. Maybe that's just me. But anyway, you've got a C# server and client running in a mobile device. Basically, it just takes advantage of web views in native apps for Android and iOS. So basically, you've just basically got a website running locally on your app. So then you've got one C# code base that you can deploy to both Android and iOS, which might be convenient for your use case. Cool. I'm going to go through a few more of the details here. So, basically, all the components that you have, all of the sort of the rendered fragments you get in Blazor code are .NET classes. And I think being a .NET also don't need to convince you how useful and powerful classes can be. So this is obviously a really nice feature of Blazor. We can also do things like binding of parameters. We saw that briefly with the increment count where the number was increasing. But also one of the examples I like to give is if you have a HTML checkbox and I've got a Boolean variable on my server, but they're both kept in sync if you bind them correctly. So if I had an unchecked tick box, that would match to a false flag on my C# server. And if I changed that to true, the checkbox would tick. And then vice versa, if I click to untick the checkbox, that would change my variable to false. That's quite a simple example, but that's kind of what's going on behind the scenes, that two-way communication. And then also as well, Blazor has a way of, it has like JavaScript interoperability. That's a really big word. That allows you to basically call JavaScript functions on the client side. And there's also a way, if you set it up correctly, for JavaScript to then call back to C# functions as well, which is obviously, again, really, really powerful. And I slightly lied before when I was talking about WebSockets. It's actually, obviously being Microsoft, it's maintained by SignalR, which on a hunky-dory day means it will be WebSockets. But if you know your connection degrades, it might degrade itself down to like server events or long polling if the connection's unstable for whatever reason. So that makes it a little bit more robust, I guess, in the communication side. And one thing I want to make really, really, really clear is where all of your code's living. So in the top box there, this is, for example, the server side of rendering, where basically your server's doing all of the rendering, and you have your .NET runtime over down the right on the server, and you have the server's own document object model. Again, big words. On the server, and basically sending HTML diffs each time that updates down the client. And on the client, you've just got a small JavaScript library that's just handling all of those diffs to then re-render the page and then sending back events to the server. And importantly, again, your app code is living on the right-hand side in the server. On the bottom one here for the WebAssembly, we've kind of got a completely different way of going on in that we're fetching all of the code and the .NET runtime. And your .NET runtime and WebAssembly and your app code are all sitting locally in your client's web browser, which is really, really cool. So if you're interested in Blazor, these are some of the resources I use to compile this section of the talk. The .NET Show is really, really good. It's a good, fun podcast. And Blazor University is really good for lots of different tutorials. And obviously Google is quite good. Or your favorite flavor of search engine, however you would like to take that. Cool. I'm going to talk a little bit about WebAssembly, and then we'll have a pizza break. Cool. So I think I've already mentioned most of these points, but I'll remake them. So again, just to be really clear, WebAssembly runs in web browsers. It's kind of a little bit lower, I guess, in the tree of how high or low a programming language is, in that you compile to it. And on the WebAssembly website, they quote it as portable binary code format for executing programs with near native code execution. So like it's definitely like a lower language. It's not interpreted. It's already most way there. And it advertises itself not as a replacement for JavaScript, but more something that complements JavaScript and does things that JavaScript can't do. Mainly for performance reasons, I guess, is that one of the main reasons that they say to do it. The WebAssembly spec is maintained by the World Wide Web Consortium, the W3C logo in the top right. And importantly, they've had the input of all of these big companies in the orange box at the bottom. Again, including, let's see if I can remember all the browsers, Mozilla Firefox, Microsoft Edge, Apple WebKit /Safari, and Google Chrome. Obviously, again, having buy-in from all those people means that they're going to get it right, and their web browsers are going to support it really well, which is good. Again, I think this is the third or fourth time there's been the slides. WebAssembly runs on web browsers. And again, I think I mentioned for performance reasons, kind of they say the best way of going about it is, roughly speaking, this is very blanket overview, but use JavaScript for non-intensive things and WebAssembly for more intensive things. So there's a little website at the bottom right here called madewithwebassembly.com, and it gives some examples of real-world applications that are making use of the benefits of WebAssembly. So for example, Figma, if you haven't come across Figma, you like designers use this software to basically mock up applications for developers to then program it into their code. And I guess being design software, I guess there are some intensive things that go on in the background there. And eBay, apparently they have, well, when you go to sell something, one of the options of getting the product information is to scan a barcode of the item you're trying to sell. And on lower end devices, they found that their JavaScript real-time scanner with their camera was performing really poorly. And basically, apparently, according to the blog post I read, they rewrote it in WebAssembly, and most of those problems went away. WordPress Playground. I don't know if you've come across WordPress before. I don't know how true this is, but until recently, if you went to the WordPress website, they said something like 70% of all websites are run on WordPress. I don't know how they calculate that number or whatever. But anyway, it's very commonly used. And WordPress Playground, interestingly, you go to this website and it downloads the WordPress sort of source files for you, and a PHP server that's compiled to WebAssembly, and a database server that went to WebAssembly. So basically, by going to WordPress Playground, you can spin up your own local stack of WordPress completely in your web browser. So if you wanted to do some quick testing or something like that, and you can be bothered to faff around setting WordPress up, you can go to WordPress Playground and just have a full stack one running in your browser within less than a minute, which is really, really cool. And Photoshop are apparently in beta of their image editing software in the browser as well. And apparently BBC iPlayer are also going to be releasing a new video player in WebAssembly too. The kind of things that's not so good for, I'm not going to tell you off if you do use them for these applications, but you're not going to see any of the benefits, is things like blogs. These are things that are generally generated server-side and then shipped down. Your normal, everyday create, read, update, delete apps. And also SEO critical apps. I mentioned before, if you've got a WebAssembly app, it might actually take a few seconds to download all the WebAssembly files and actually initialize the page, which is obviously terrible for search engine optimization. And also, WebAssembly is not very good for heavy DOM manipulation if you're changing things around the page. As I understand, WebAssembly doesn't actually have direct control over the DOM. The way you would get your WebAssembly app to update the DOM is basically to speak to the JavaScript API and say, find this element, update it. You can't do it directly inside WebAssembly. On the next page, I've got a list of languages, according to this website at the bottom, that compile to WebAssembly. So I'm going to hazard a guess that quite a few, I don't think there's going to be anyone who's programmed before is going to find a language on there that they've not programmed it before. I mean, feel free to prove me wrong. The point I'm trying to make is there's a lot of languages here which already have a compiler that compiles to WebAssembly. So yeah, if you've got some client-side code that you could take out of your possibly monolithic app and move it into client-side WebAssembly, why not give it a go? That'd be cool. This is the point where I'll stop before doing demos. And is pizza ready, or should I can crack on with the demos?
It's saying estimated arrival between 2 minutes and 22.
Ooh, I don't know if you heard that online, but pizza is between 2 and 22 minutes away. So
yeah, I'll take crack on. I don't know how fluid you've got it to.
Yeah, we can interrupt it. Also, I didn't point this out. If anyone's got any questions at any point, as long as you don't completely derail the talk, I'm happy for interruptions with questions. So if you have any, now's a good time. That goes to people online as well. Sorry. Yeah, go for it.
SharePoint.
So the question in the room was, how does it deal with SharePoint?
Is there integration with SharePoint?
It's a good question. Microsoft seem to love SharePoint. It seems to be integrated with everything. But honestly, personally, I try to avoid SharePoint like the plague. I don't know. Honestly,
No.
Presumably there's something. Yes, do you want to go ahead?
They still have front ends where you usually use frameworks to play my sins.
Mm-hmm.
Blazor have like the things like Tailwind and UI frameworks.
Yeah, so it's a good question in the room. So I'll not degrade your experience as you try to do that. I'm sure you know what you're doing. But the question was along the lines of, does Blazor have support for basically front end frameworks? And the answer is, roughly speaking, I'm not so familiar with them. There are some nice UI packages that basically have some nice HTML and CSS components pre-made for you, which you then ship down to the client. I know there's then other ways of, if you've got some JavaScript client-side libraries, you can also interface with those, which is a little bit more awkward. Does that sort of answer your question? So
It seems like you got like a pre-written table and all the sorts of because they bind to the table. Those components, the lasers, the laser.
yeah, I'm not 100% sure.
Yeah.
Someone else might know in the room. I'll also try and repeat online.
It's like they build libraries for Blazor. So you can incorporate those into your Blazor project. Yeah. And so they're styled to use Bootstrap, solid syntax, for example, Bootstrap, Tailwind, and you know.
There you go. So I think the answer to the question was yes, it does exist. There are some pre-made Blazor libraries that have some pre-made components for things like Bootstrap.
Oh, some of them are free. Yeah, that's true.
Some of them are paid and some of them are free. Yes, I'm sure that's the case. Cool. So I'm now going to move on to some demos. Unless there's any questions online, I can't actually see the chat. So do shout out, Jess, if there's anyone who has a question.
Good.
Cool. Again, feel free to interrupt me. We can stop and take that. But now I'd like to, it wouldn't be an interactive web app talk without some interactive demos. So can you either go to that URL in the bottom left or scan that QR code and it'll take you off to a website where I've got some demos waiting for us to have a play around with. I'll leave it on the screen for some period of time. Maybe I'm just waiting for everyone in the room to put their phones down. I think we're almost there. Cool. I think we're near enough there. What I'll do is I'll leave the link in the top right, so the QR code will disappear, but the link will still remain. Cool. So I've got 7 demos waiting for us. And I'm sorry to say that the first 3 are really boring. But if you want to open them up anyway, that would be great. What I'm going to do is I'm going to bring it up on here as well, so we can see my copy as well. So when you head over to that website, you should hopefully see something like this. So I'm just going to resize the window. There we go. And basically, these first 3 apps are super duper boring in that if you open up Visual Studio and say, I want a new Blazor app, this is the default app you get, which is really, really basic. So if we go on that second tab there, there's the counter page I showed you from earlier. We can click it in increments. And there's also a little weather API one as well. But the thing I want to demonstrate out of these 3 examples is there's 3 different hosting models going on here. So this demo one, the Blazor server one, is one where everything's rendered and the state's kept on the server. The second one is one where everything's done in WebAssembly on the client side. And then the third one is that weird auto type of hosting that I talked about earlier. And one thing I do want to demonstrate is if I go back to the example, I'm going to open examples 1, 2, and 3 in a new tab, and I'm going to turn off the servers, and you can see how they cope. And you can see the second one, at least, will continue to work no problem because it's completely browser side and client side. So I'll encourage you to open up examples 1, 2, and 3 new tabs if you can. I don't know how well that'll work on mobile devices. It might work better on a computer like this. So you should see that all 3 of these apps work in exactly the same way at the moment. In about 10 seconds time, I'm going to turn them off, and you can see they're going to behave slightly differently. Okay, I'm going to go ahead and turn them off. And try and turn them off.
You also want me just die.
There we are. Yeah, so it'll either die and go to my CloudFront page, fantastic. I wouldn't normally say that, but fantastic. Or you'll get like a little grey screen with Blazor that can't communicate. But important, the second one, I can click that counter to my heart's content because it's all WebAssembly and it's running locally. There's no server state kept for this application. And it looks like the auto one didn't work this time because the auto decided to use the server rendering rather than the client-side rendering. But if you refresh that page a few times before I turned it off, you might have got lucky and got the WebAssembly rendering to work. Cool. So I'll turn those back on and we'll move on to the next demo. Sorry. Cool. So demo 4 is a really, really silly form validation example. And this uses completely client-side WebAssembly. In actual fact, in this particular example, there's no two-way communication kept with the server. There is no server-side code. It's only client-side code. Again, I'll fire up the demo page. Again, it looks like the standard example, but if you go to the burger menu on the right-hand side or form on the left-hand side, you'll just see a form like this. And it's got some really silly validation. And by silly, I mean, you can't leave your name blank, but you also can't have it set to Adam. So if I type Adam, it will tell me in that particular field. There's only one true Adam, don't lie. Sorry, this was really silly. I'm going to call myself not Adam. And it'll pass the validation. Obviously, reference is the most important meal of the day, so we have to make sure that's ticked. And we also need to put in our age for some reason. Yes, that's a little reference to the first JavaScript example earlier. But something I want to demonstrate here is the HTML checkbox binding that I was talking about before with the Boolean flag. So there's a little snippet of code just hanging off the bottom of the screen there, which is some Razor code, which is just binding to a Boolean variable in my C# class. And I've actually got this bound to the same two HTML checkboxes. So I can tick this box, and what's going on there is it's updating. Well, I was pointing off to the server. There's no server here. It's pointing to the WebAssembly files inside the web browser, update that Boolean flag. But at the same time, that's also coming back and saying, oh, I'm bound to this other checkbox, so I'm going to update that as well. And likewise, if I untick that box, it unticks the other one, because again, they're bound to the same variable, and it maintains that sync for you, Blazor. So if I tick that and click update, it will say, thanks, not Adam, for submitting the form. That hasn't actually submitted anything. I haven't just harvested all of your personal details. It's completely local. Cool. All right, I'll move on to demo number 5. Get some water. Okay, cool. So this one's a real-time chat. Can I just say, if anyone says anything too rude, I will have to turn it off. So can you all be sensible, please? Please. But if you go to demo number 5, enter your name as you open it, you can then do some real-time chatting. So hopefully no one's taken Adam yet. There's a hello over there. Someone's got not Adam. Nice. I like that. Interesting, it has actually got a profanity filter, which is one of the NuGet packages I installed on here. So if I type in hell rather than hello, it tells me off. Sorry for saying hell. Hope no one minds. But it says message contains a profanity. Please remove it. But if I don't, it's all good. So we can send a few messages. Yeah, cool. And what's really nice is between all of your personal devices and the server, it's maintaining that two-way communication for you. And every time there's a new message, it's pushing it out to everyone's device, and it's maintaining that synchronicity for us, which is really convenient. And actually, I'll make the code is already available on my GitHub. I'll put a link to it on the end. You'll see how simple the code is for this. It's not hard. It's maybe like 100 lines of code, and some of that's boilerplate, making it look nice. So yeah, I was quite pleased with this, that it wasn't too difficult to code up or anything. So let me just go out the slides and talk about it a little bit. So yeah, it's a real-time chat. It's got some event handlers, basically a singleton C# web server service, which has just basically got an array of all the chat messages and who sent it. And in actual fact, I've added a little bit of logic in there that it uses some client-side browser storage just to remember who you are. So if you refresh the page, it would remember you either were Adam or not Adam. And it would sort of log you in as such, and you would continue the same session that you had before. Obviously, being in .NET and C#, there's lots of NuGet packages available. So I know we were talking about UI packages earlier. There's this really nice one called Blazor. Yeah. So I definitely did design this chat interface, and it comes pre-built with some components. So basically, I'm saying on the screen, I've got basically a for loop of all the chat messages. I'm just saying on each chat, render a new chat component for me. There was a little bit of logic I had to do with this other package called MoreLinkQ to basically group things together. When you've got multiple chats, it doesn't repeat your avatar. So that was a little bit of fun LinkQ code. Also, if you use C# and you don't use LinkQ, LinkQ is arguably the best feature of C#. I love it so much. It's amazing. I forgot what it stands for, language integrated query, something like that. It's really, really powerful, really powerful. And then there were also a couple of other packages I included here for the local storage and the profanity detector stuff as well. Cool. I did just see Connell leave the room. So do we do demo 6 or do we wait for pizza? What do we reckon? Demo 6? Cool.
I'll have to leave them all alone.
That's right. That's true. Okay, so demo 6 is a real-time game. So again, if you want to fire up, oh, sorry, that's doing demo 7. Oh, golly. Ugh. Right, where's my window? Feel free to beat me to it if you want to head straight up to demo 6. So when you fire that up, you'll see lots of different characters here. Someone's already taken a particular piece. You can't take it because they've already taken it. So you have to pick a new one. So I normally go for the penguin. Oh, right. I'm gonna go for the cat. Okay. And what's really cool is you can drag your player around, but everyone else can drag their player around as well. And again, Blazor is maintaining the synchronicity of this game for us, which is really, really convenient. So interestingly, there's a few ways this mechanism works. So I've got like using the JavaScript API for Blazor, I've got an on-up mouse click event. So basically, each time you let go of you start dragging your character and you let go, it's going to force push out an update for everyone. But if you also drag it really, really slowly, it maintains basically real time. It's already having to tell the server I've updated my character's position. So it's also just getting back everyone's character at the same time. So there's a few ways of making that work. So if you look, everyone's moving around quite smoothly at the moment because I'm dragging it slowly. But if I let go, they'll move in big jumps because it's waiting for the next update to be pushed out. So if that makes a bit of sense. And again, the code for this is really, really simple. There's just a service that tracks the pixel location of your character. And on certain events, we'll push that event out to all of the clients that are connected using a Signal R hub. Ooh, the door has opened for pizza. Connell's going to lay out pizza. I'm going to do demo 7, which is the final demo. We'll do a quick summary, and then it's eating time. Cool. So demo number 7. So I said I worked at a company called Savoy Systems before that did cinema and ticketing software. So it was only right to make a seating plan selector by Paul. So if you want to fire up demo number 7, I'll try and get there. And basically, so that's bigger. And basically, it won't let you pick a seat that someone else has got. So if I select E1, hopefully that's gone great for all of you. And if I release it and someone else picks E1, go on, someone get E1 for me. Thanks. They've now claimed that seat, and until they release it, no one else can pick it. It's what says we never got to the state of being able to use this kind of introduction, but it's a nice idea that when you're booking for the theatre or the cinema, that's a really useful feature to have, right? Where you don't book a seat twice that someone's already got in their basket, for example. So that one's all taken. If you want some more fun, oops, I didn't mean to do that. There's a some later talk, which has got a lot more seats, so you can go crazy on this one. I'm sure someone with more skill than me could do some, I don't know if you call it ASCII art. I guess it's not ASCII, is it? But you could do some nice little artwork in the seat selector. Pixel art, I guess. Yeah, that's right. Cool. That's filling up very quickly. Nice. Cool. And that's the end of the demos. So I'm going to do a little bit of a summary. So in those demos, I demonstrated some of the different hosting models, the difference between basically having your server doing the rendering and your client doing the rendering. I demonstrated some of the data binding things with, those checkboxes where basically a Boolean variable was updating with a HTML checkbox in real time. I demonstrated that silly form validation one where it was entirely WebAssembly. And actually something I should have done is I should have turned that one off on the server as well. Because again, you would have seen that it would have worked completely in your browser. But if you refresh the page and try to re-request the resources, then it would have fallen over. Blazor being in .NET and C#, you've got rich package availability through things like NuGet. It's a widely adopted language, and there's a lot of community-made packages out there. And then I showed with the games and the chat and the seat selector, some real-time event handling and Signal R hub handling going on there. And again, something I want to stress is these things are super easy to code up. I'll make it easy for you to get the code from my website, but it's honestly terrible. Also, you'll probably find some horrific bugs in my code. Don't judge me. I did put it together quite quickly. But again, just to stress, in 100 lines of code, you can make each of those applications, which I think is really, really cool. So in summary for the talk today, Blazor is pretty cool. and WebAssembly is also pretty cool. So thank you very much for your attention, everyone.